Welcome to the session number 1 from the playlist of electromagnetic waves. This is the first session from the playlist of electromagnetic waves, or you can say from the chapter of electromagnetic waves. And in this chapter, we will be discussing about the characteristics of the electromagnetic waves. We will be discussing about the conduction current. We will be discussing about the displacement current. We will be discussing about the Maxwell's equation. We will be discussing about the transverse nature of the electromagnetic waves, and finally we will be discussing about the spectrum of the electromagnetic radiation. So today we will be discussing about the characteristics of the electromagnetic waves in brief, and based on this topic I have written here a few important bullet points. So the first point here is that stationary charges produce electrical field only. If the charge is stationary, then only the electrical field will be produced by it. But if the charge is moving with a constant velocity, then it produces both the electric and the magnetic field. So both these 2 points are very, very important. Now, if the charge is accelerating, or accelerating charges produce electromagnetic waves. So this is the topic which we will be discussing in detail in the subsequent sessions. So electromagnetic waves are those waves in which the electric field and the magnetic field are perpendicular to each other, and they are varying sinusoidally with time. Apart from being perpendicular to each other, they are also perpendicular to the direction of motion of the wave. That is, the electrical field is perpendicular to the direction of propagation of the wave, and the magnetic field is also perpendicular to the direction of propagation of wave. Next point is that the electromagnetic waves propagate in a medium with a speed which is given by this formula, that is C is equal to 1 divided by under root of mu into epsilon. Now here mu is the absolute permeability of a medium, which is equal to mu naught into mu r. Now mu r is the relative permeability of a medium, and mu naught is the permeability in free space. Epsilon is the absolute permittivity of a medium, and this is equal to epsilon naught into epsilon r, where epsilon r is the relative permittivity of a medium and epsilon naught is the permittivity of free space or vacuum. So in the case of vacuum or free space, since the value of mu r and epsilon r is equal to 1, therefore this equation gets converted into C is equal to 1 divided by under root of mu naught into epsilon naught, because in the case of vacuum or free space, the value of mu r is equal to 1 and the epsilon r is also equal to 1. Here mu r is the relative permeability of a medium, and mu r, this epsilon r is the relative permittivity of a medium. So if I substitute these the value of mu naught and epsilon naught in this equation, that is mu naught is equal to 4 pi into 10 to the power minus 7, and epsilon naught is equal to 8.85 into 10 to the power minus 2. So if I substitute these two values in this equation, I will be getting the value of C, which is approximately equal to, the correct value is 2.99 into 10 to the power 8 meter per second. So this is approximately equal to 3 into 10 to the power 8 meters per second. So this is the speed of the electromagnetic wave in vacuum, which is approximately equal to 3 into 10 to the power 8 meter per second. Now next important point is that the electromagnetic waves are transverse in nature, whose speed depends on the medium, but their frequencies doesn't depend on the medium. Now EM waves are transverse in nature, meaning that the particles of the medium vibrate in a direction perpendicular to the direction of propagation of the wave, and since the particles of the medium are vibrating in the direction which is perpendicular to the direction of the motion of the wave. Therefore, the EM waves are transverse in nature and their speed depends on the medium in which they are propagating. And their frequencies, however, doesn't depend on the medium. Now, the next and the last important point for this session is that the electromagnetic waves can be polarized. By the word polarized means that in the case of electromagnetic waves, the vibrations in a particular direction can be restricted, and these vibrations are perpendicular to the direction of the propagation of the wave. These electromagnetic waves, like other waves, they also carry energy and momentum from one point to another while they are propagating in a medium. And so this is all I have for this session. So the most important point for this in this session was that the electromagnetic waves are means they propagate in a medium with a speed which is given by this formula, that is c is equal to 1 divided by under root of mu into epsilon. And apart from that, the electromagnetic waves are the waves in which the electrical field and the magnetic field are perpendicular to each other, and at the same time they are varying sinusoidally with time. And apart from being perpendicular to each other, the electrical field is perpendicular to the direction of the propagation of the wave, and the magnetic field is also perpendicular to the direction of propagation of the wave. Here the most important point is that EM waves are transverse in nature and their speed depends on the medium in which they are traveling, or means these EM waves are transverse in nature, whose speed depends on the medium in which they are propagating, and however the frequencies doesn't depend on the medium of propagation. EM waves can be polarized and they carry energy and momentum along with it. So thank you very much for joining this session. In the next session I will be discussing about the conduction current and the displacement current, and thereafter I will be discussing about the Maxwell equations. So till then, have a nice day. Bye.